Hello, everyone. I hope you're doing well and safe. I'm Amel Azzi, software engineer, and actually, I'm studying IoT and doing my internship at Orange Business. My mission is to create shared libraries for Android and iOS with Kotlin Multiplatform. Today's sessions, we will talk about first step with Kotlin Multiplatform, where we will see general aspects of KMP, and at the end, if you will have enough time, we will show you how to create your first KMP project. First of all, I would to thank our original lead, Salim Abid, and all GDG chapters for taking this initiative and their great efforts for this event, which began in March and will end in October, inshallah. So you can join all the event sessions in the GDG MENA YouTube channel, where you can find the daily agenda of the week. And don't forget, of course, to subscribe to our channel. Also, you can find our global agenda, where we have a theme per week. And now we are in the week 11, where the theme is Kotlin and Android. So you can go for the themes and the weeks for all during the event. So I can say again, hello world. For simple applications or projects, we just need to build our application with a single targeted platform. But the more the application is important, the more we need to develop it for several platforms, such as Android, iOS, for web, and even for desktop. So the societies came up with an idea, and with a wild application idea, which says develop the application for Android and iOS. And for this, we use native platforms, which is normally good, because we will hire more clients and users. We will have users for Android and users for iOS for our app, and by this we will make more money. But behind the scenes, all we need to build this app is to hire a theme for each platform, hire a team to develop our Android application and another team to develop the iOS application. So we need also to define the requirements for the application, design the mockups for both platforms, iOS and Android, plan features development, and then we can start developing the application. At the end, we of course check the functionalities by the unit test. Once this finished, we do a cross-checking validation between both platforms to see if the two applications are responding and answering all the functionalities in the same way. So by this, we notice that we will double all our efforts and costs. We will have two teams. We will double the cost of the project. We will have double meetings for the Android team and the meetings for the iOS team, development time, and don't forget the testing time that we need to test both of the application. And the most important thing is fixing the bugs, which I think that take lot of time. So the societies, when they saw that they are hiring more users while developing their application with Android and iOS, so they came with another wild application idea, which is develop the application for Android, iOS, and web. But in this time, we are not just doubling the things, but they will be tripled. We need to do the same things for each platform. So, for Android, iOS, and even for web, we need to do the same things for each platform for Android, iOS, and web 3 times. So we are tripled the developing time, the testing time, the fixing bugs, and so on. Even the team, we will hire 3 teams, one for Android, iOS, and another one for the web. So what is the solution that will work with all platforms? I think that you can guess. Yes, it's to use the cross platforms. This solution will build a single application where we will write the code once and run it in different platforms. So here I will show you history showing the main cross-platforms that appeared since 2011. In 2011, the Xamarin came. It's developed and owned by Microsoft, and we can use Xamarin tools to write native Android, iOS, and Windows apps. Ionic came later in 2013, which is an hybrid mobile app development written in JavaScript. Then, in 2015, React Native showed up, which is an open source mobile application framework created by Facebook. It's used to develop applications for Android, iOS also, and web using the React programming language. I believe that the React Native is used more than for Xamarin and Ionic. So in the same year, we have NativeScript, which is also an open source framework used to develop apps on the iOS and Android platforms. I've already tried the NativeScript, and it's really similar for like developing web applications using the TypeScript, JavaScript, and it's really, really similar. We can use with it the Angular. So after this, 2 years later, JetBrains released the Kotlin Multiplatform. Kotlin Multiplatform is also an open source based on the popular and modern language, which is Kotlin. And finally, as you know, all of you, I guess, we have Flutter. So Flutter was born in 2018. It's an open source UI software developed by Google, and it's used to develop applications for Android, iOS, and web, and even for desktop applications. For all these cross platforms, they have advantages. So we can notice that we can save time by developing our application once and have many targets. So we need also only one team for the development, so we can save money. And these cross-platform are using familiar programming languages, which are easy to learn, like NativeScript, which uses the JavaScript, the React Native using the React programming language, and for the Flutter is using Dart. Even that is an old programming language, but it has its weight on the technology today's. It's true that we have just seen the benefit of using cross platforms, but they have some flaws that we can mention. They have to change to the framework implementation of UI. And second, they don't offer the same performance. When we use these frameworks, they don't offer the same performance for the Android generated application, for example, for the iOS application, and even for the generated web application. The device features are dependent on the framework support, so we will have some limits for this. Example, if we use the iOS and Android, if you use the cross-platform to generate iOS and Android application, maybe we will have some libraries that Android will accept to use, and the iOS is not allowing this. And for this, we might add native code for our code to allow this application run in a targeted platform. And these cross-platform are also committed to one framework and languages. So I think that they are really limited. So how can we have the best of both worlds? Of course, by using the Kotlin Multiplatform, which is our main subject of today. So let's take a deep look to KMP, which is Kotlin Multiplatform. So Kotlin Multiplatform is developed by JetBrains, and now it's supported officially by Google. Since Google supports Kotlin Multiplatform, this language has not stopped growing. Kotlin is becoming the most popular programming language for mobile developers. There is a huge of mobile developers which switched from Java to Kotlin, for mobile development, and the new mobile developers started developing their mobile application directly with Kotlin. So for similar reasons, and most of all, we use Kotlin for its clean, easy to implement code. I think that developers who used to use Java to develop Android applications, when they migrate to Kotlin, there is a lot of functionalities, or a lot of functions that they used to code with Java with like 10 lines, but with using Kotlin, maybe we can just use the Lambda function and some features that Kotlin provide to developers rather than Java ones. So Kotlin also, it was even chosen as the second most popular programming language in the Stack Overflow developer survey. I think that it was in 2018. So the main Kotlin's goal of being implemented across multi-platform, but we see Kotlin as the premise of a much more important goal, that which is the code sharing between platforms. It can be compiled and run natively on iOS, macOS, Linux, Windows, WebAssembly, and even for embedded systems. So in this, we can see the power of using Kotlin multi-platform. In addition, we can use it for the backend and even for the front-end sides. So, for example, without using Kotlin multi-platform, we need to code our business logic for each platform. For example, for the JVM, which is Java Virtual Machine platforms, JavaScript platforms, and even for native platforms. So we will code our business logic 3 times. But with Kotlin multi-platform, it provides us the ability to code and to have a common business logic which will be shared between the 3 platforms. So with Kotlin multi-platform, we can share the business logic, but we cannot share the application UI. The UI of all targeted platforms will be native ones. So let's talk more about Kotlin multi-platform advantages. Why should we use Kotlin multi-platform rather than the others? So first of all, KMP is an SDK and not a platform. This is the biggest advantage of opt-in for Kotlin, is that integrating and migrating and are progressive form a single module or function whose operating is determinate. And for second, we can reuse our business logic, because KMP allows us to separate the business logic layer from the user interface layer, which will be and stay native, using shared logic and libraries under the UI layer. For this allows us also to interact with a native environment without using brace and providing code more natively, which is impossible with the previous cross platforms that we have seen. We also need, most of the time, we need to code a bridge to pass from a platform to another. The third one is that Kotlin multi-platform provides a smooth interoperability. With a code specific to the platform, any task that cannot be resolved in the common code part, it can be implemented using the expect actual model that we will see after, to write code transparently for the targeted platform. So, as I said, if we're not able to code some functionality or have a class which is specific to one target and not to another one, Kotlin multi-platform provides this ability. We have the possibility to code a specific object or specific code for only one targeted platform and not for the others. So as I said before, we with the Kotlin Multiplatform, we also have a native UI. So Kotlin does not impose any restrictions on how we develop our app's UI. Its appearance, behavior, and even performance remain and still native. Kotlin Multiplatform also provides us a high performance that the other cross-platforms cannot provide, because the performance change from targeted platform to another. But with Kotlin Multiplatform, it compiles the code in the same explicit format as the target platform, and this makes it efficient as its native counterpart. And for the sixth one, and not the last and not the least, it improves flexibility and scalability. So it allows us to scale application project and operate without using a virtual machine. So we can create mobile applications while we are focusing on the factor of flexibility and scalability. Here we have a diagram that we see here summarizes the different platforms where we can compile and execute KMP project while respecting the principle of having the same business logic. So we can have Kotlin Multiplatform is able to compile and deploy the shared code in several platforms, as we can see here for Java Virtual Machine, JavaScript, and native. And for each platform, it's allowed to be compiled in different outputs. So for example, and how this works. For example, if we take an example like, if we take the example of Java Virtual Machine, so this generates jar files which allows Kotlin to be used by Java projects such as Android and even Spring Boot using the JDK Java 6, Java 8, and I think that's even the latest Java for the, I think that we can use it also for the Java 11. And for the JavaScript, it would generate JavaScript files which can be used in other JavaScript files, and this allows Kotlin to be used in other frameworks like React for the browsers and even for the Node.js. For the third part, the native part produces a binary code that allows Kotlin to be executed by native platforms for any native platform. So the Kotlin Multiplatform produce a binary code for a native, and we don't know which target is, but the code generated can be used for any native targeted, like we can use it for the desktop, Linux, Windows, and Mac, for the iOS and for mobile, and even for the embedded system like the STM32. And in this second schema, we have a schema providing an example that resumes the working process of KMP for an Android and iOS application. For the first step, we begin to write the shared code business logic between the two platforms in Kotlin. So the common package will hold all the common stuffs between the two targeted platforms. In the second steps, we will generate the code which will be executed in the both platforms. So let's begin with the Android side. The code is converted to Java bytecode, which can be executed in the Java virtual machine. Thus, Android already having the virtual machine is easily able to run it. So that's why we call it a direct process. We don't need to use other libraries or frameworks to run our project in Android platform. But in the iOS target, the code must be converted into native source code executable on the iOS platform. However, the Kotlin compiler which is called Conan, uses a set of iOS resources and frameworks that you will merge with the common code and generate our iOS application. So the Conan is not generating a bytecode that will be directly used by the iOS, but it will use other frameworks and libraries, merge the bytecode, the generated bytecode with the frameworks, and use some iOS stuff to generate our iOS application. Now, I think it's time to understand how the Kotlin compiler Conan works. So Conan consists of two parts, front-end and back-end. So the front-end part has the role of converting the Kotlin code into a so-called intermediate representation. This intermediate representation is converted into native code executable by the machine using the backend part. So here we have the backend. Here we have the backend part has the role of converting the intermediate representation into native code using the Kotlin native infrastructure built by the JetBrains. And basically, as we said before, for Android, it converts the intermediate representation to Java bytecode, and for iOS, it converts the intermediate representation native code executable by the iOS machine. But if we think deeply about all this cross-platform, having several targeted platforms, have common code and a specific code for each targeted platform, we can ask a question that how all this will communicate, how all this they expect to communicate. So this by using two keywords. In the common main, which means we use the expect word, which means that we expect to find this object or class or whatever we want in the targeted main. And for this, we use the keyword actual in the targeted platform main to say that this is the actual object or class or even function that we expected to find here in our target main. So in the beginning, we have the common main. We will code our application with using the Kotlin programming language, right? So all our files will be of the extension Kotlin, KT. So if we have the expected objects in our common main, we should have the actual objects in each target platform for the JVM, native, and JavaScript. And this, after compiling, the iOS can't use directly the Kotlin files. So after compiling, it will generate files that can be used in iOS, like C, Swift, and other frameworks. And even for JavaScript, it will generate JavaScript files. For the Android, we have Java and jars. So I hope that you have a brief idea about Kotlin Multiplatform now and the power of it, that we can reuse it, the business logic, and how many platforms we can target with only one code without using any bridge. So to summarize this, I will present you. I will show you how to create your first project with Kotlin Multiplatform. So for this, we will need IntelliJ to create our common project, and Android Studio to we don't even use Android Studio because we can run Android application on IntelliJ IDE, but for the iOS part we need to use the Xcode. So let's start by creating a new project, and on this the sidebar, you have to choose Kotlin, and here you have several options. So if you want to create your project, mobile project, Android, iOS, you have to choose this one. And you can even create shared libraries between Android, iOS, or other platforms that you want. You have to choose this one. For our example, we can choose the mobile Android, iOS project. We'll let this here. And I will give a name, the KMP, like Kotlin Multiplatform Project. So here we can see that the project is generated. We will wait for the building, indexing, and generating all the files for our project. So as all projects, we always begin with the hello world function. Yes, here we have not really a bug, but we need to specify the path of our Android SDK. So I've already saved this. Sorry. And for this, we have to synchronize our Gradle to take on consideration our modification and find our SDK. We have a successful build. So here we can see our project structure. So here in the main package, where we have the source. So here we have the different mains. We have the common main, and in this package where the magic will happen. So when you have packages for the test, we have also a package for the iOS main, and this main is for the Android main. And as you can see, is such an Android project that we will create with Android Studio. We have the resources here, layout, values, and even we can create our packages. We also have the Android manifest, and in this package we have our run our simple application by default. So as we said before, in this common main, we'll have several things. So this is a default project that we have when we create a new project, excuse me, a new Kotlin Multiplatform project. So here we have two objects declared as expect. So we have an expect class, which called simple, and an expect object with an attribute, which is the name. And for this, we have a function. So as we have said before, we need to have this class and this object in the targeted platform as actual. Don't focus on this, so we will explain this later. So if we check this, we will see the same things, the same object and class declared here in the iOS main. We have here actual class simple and actual object platform. And this, it's just like we declare our model, the structure of our project. And here in the targeted platform, we should initialize our stuff like the attribute and this function. Also, we have the same thing in the Android side. We have the initialize function for the check me and the name of the platform, which is Android. Of course, we can change this the string, the name, and all what we want. As you can see, in the iOS side, that we have only the actual object and class. But for the Android, we have an activity which is declared here. Because as we said before, it's a direct process. We have an activity, a simple activity, as we can have it in Android Studio project, where we create our bundle and so on, and set our layout exactly as the Android project that we know. And here, what we have is we get the ID of our text view where we will print something. So here you can see our activity main, the layout of our activity main, and you can have, I think, that the Android structure, yes, to be more easy to read it, yes. So if waiting for this to load, sorry, we can go back to this simple class, which is here in the common main. So here we have a function called hello, which returns the strings hello from platform.name. So they take the name of this platform. And a class which is called proxy, they have a proxy which returns the same string as hello. This proxy is, you will see that it is used for the iOS side. And for the function main, we will see that we need to print this hello, print it in the iOS and for the Android platforms. So that's why here in simple Android, we have the when we had the our text view text, we affected it the return value of hello, which is function hello, which is hello from platform name. So the value of the platform dot name here, it will take this one, the declared actual object. So in our Android, we will have hello from Android. And for our iOS, we will have the hello from iOS. Before starting building and running our application in Android and iOS, we need to do some changes. Here we have a file package Gradle wrapper that we need to upgrade to, I hope that you can see like this, to version 6.3 because I've tried, I believe that while using the Kotlin Multiplatform for the first time, you will have several bugs of version dependencies, and you will struggle with this as I did me. So we have to upgrade this to 6.3. And for the default one, they have this 5.5.1. So for not having bugs while compiling, the compiler won't know which version to use. We have to add two instructions to our Gradle saying that for all platforms, you will use the Gradle version 6.3, the same one that we have set here in the Gradle wrapper properties, and here for all platforms. And what we need to do also is to change the build the Gradle plugin for Android, because for each version of Gradle version, we have the compatible version for our plugin in Android. And for the 6.3, we have to use the 3.6.01. So we synchronize our Gradle once again to take all the changes on consideration. You can wait for this. Okay, now we have a successful build. So here we can remove this package, not have ambiguities between the version. And now we have to run our application in Android application with IntelliJ. So for this, we need to say to IntelliJ that you have to take on consideration this class. So what we need is add the configuration and add an Android app that we can give a name for our main. For not having ambiguities, we can use Android main, apply. Okay, and this we can run our Android application in our emulator. It says that there is no SDK. Yeah, I didn't choose the sorry, the app. We have to say that he will find the Android application in the app package. Okay, so now we can run it. This is the old one. So we have declared the hello function in the common main, and all what we need in the Android side say that our text view will receive the return value of hello function. So just have to wait for the build. It takes a little bit of time because you need to build all the projects and get the Kotlin ready. Okay, here we go, and we wait for the installation. And yes, so here we have hello from Android. If we change, for example, this string, it will change hello from, don't know, from GDG, GDG MENA digital days. We will have hello from GDG MENA digital days. So we'll just wait for the Gradle build running. While waiting this, as we said before, for the iOS, we don't execute our application directly from NTDG, and we need to do some changes, to add some changes to make our iOS application ready to be executed with with the IDE Xcode. Okay, we'll just install the application. And yeah, here we go. Hello from GDG MENA Digital Days. So now we will go for the iOS side. So for this, what we need, first of all, you have to install the Gradle plugin with your terminal. And after that, we have to execute our command line, which says like Gradle wrapper. This command line will prepare our iOS application here in our folder to be executed and run with Xcode. So here we go, we have a build successful. All what we need is open our iOS application.xcode project that we can open with our Xcode ADI. So we open it as another project. Here we have our project is the KMP that we have created in my desktop. So we'll go for the iOS app and the iOS project. And yeah, here for the iOS application, we have different UI. For example, for the Android, we are using the class, the activities and the fragments, while the iOS, we are using the views. So here we have in this class view controller dot swift. Here we call our if you remember our proxy class, which is in the main in the common class here, the proxy class, and in we do a call for the proxy hello to print our hello from platform name, which we initialized it to iOS. So we have to build this. Before this, if you have problems with building, because sometimes it's built successfully but doesn't run, you just need to go to product and then schema, then go for edit schema, and here we choose the executable for iOS app to be built and then launch the application directly after the succeed build. So if we run our application, so we just wait for the build, and here we have a build succeed, launching our iOS app, and we have our emulator running, preparing the environment to launch the application. And here we go. We have our hello from iOS. So also, if we can do the same thing as our Android application, we can see, we can say, change our platform name. If we say that Google, I think that it's not fair to use the Google for the iOS stuff, but whatever, we are Google fans. So we need to stop this because my laptop is running out. So what we need is to execute our Gradle wrapper again to take the modification on consideration, and we don't need to import our project again. We just do it once. So if we stop our building iOS and execute it and run it once again, we have to wait for the building again and again. Attention. And here we go. Here we have the hello from Google. So if you want, for example, to add another function here, saying, for example, that what we need is saying goodbye, a function says goodbye, which returns for us a string also, and we'll have goodbye from platform name. So we need to do the same for the class proxy and create a proxy to be implemented in the iOS side. So we feed this, and it will return our goodbye function. We will name this proxy goodbye, and we have to tell our main function that we have to print our hello and print our goodbye function. So here we have set our common name. If we need to use it in our simple Android application, so we need to prepare a space or a text view, for our application to have a hello text and the goodbye one. So you have to make some changes for this for linear layout, and set its orientation to vertical to see the hello thing function and the goodbye function. You can set it to wrap content. Oops, sorry. And for this we have to set an ID to give it an ID. We can say that the by text. Okay, so what we need is to set to this text view the return value of the goodbye function. So while we are using the Kotlin, we don't need to for find the view by ID. We can use directly our ID, which is by text dot text receive the goodbye function. So if uh, so it will print hello from GDG Mina digital day and goodbye from GDG Mina digital days. We will run this in the Android application, and we will wait for the build gradle also. So while waiting this for to use this function for the in the iOS side, all what we need, you remember that we have called this function hello by this proxy. So we called the class and then we targeted the function. So we will do the same for our goodbye proxy. As it's a little bit not really hard, but it's not the same how to create another view for another label for our Android iOS application. We just need to change this proxy hello for by proxy goodbye, and this is, yeah, we have got to run application for Android. So here we have hello from GDG Mina, and we have our goodbye function, goodbye from GDG Mina digital days. So yeah, I didn't run my Gradle wrapper for iOS side. So even it gave us an error, but while building, I believe that it will be built, succeed built, and we will have here goodbye from Google. So we just need to wait for build application. But we have build succeed because it takes the consideration, takes on the modification after a while. So and here we go. We have the goodbye from Google and goodbye from GDG Mena. So that's it. So I have to say to you, goodbye also for this session. I hope that you have enjoyed and you have uh, you have you have had whatever you have had an idea about Kotlin multi-platform and the and how we can use its power for to build our cross platforms. So thank you for your attention, and so you can, sorry, I didn't make this slide. You can follow me on Twitter by on my profile, which is Amelias underscore Azzi. So if we, I think that we have some time, like 10 minutes. If we have, let's check for some questions. I don't know, I can't see any questions. If any of you have some questions about Kotlin multi-platform, here we have Afaf. Why does Kotlin multi-platform exist when we already have solutions such as Flutter or React Native, or maybe the inverse? Why Flutter while we got KMP? I think that is a good question. It's true that Kotlin multi-platform is supported by Google, and Google created after a year the Flutter, to give the possibility for developers who are more comfortable with Kotlin to use the Kotlin multi-platform. For example, for the mobile developers, it's easy, which uses the Kotlin. It's really, really easy for them to build the application with Kotlin multi-platform and using for React Native. I think that the most of mobile developers also React Native is using the React. So we can say that the Kotlin multi-platform is more, it will be more comfortable for mobile developers, and using React Native will be more easy for web developers to create their cross platforms. And for Flutter, uh, Flutter is using Dart. It's completely not a new language in programming language. It's a known one, but for example, for people who they are new developers, they have small information about mobile development and web development, so they can start directly from Flutter. So I hope after that I answered your question. Uh, we have 9 minutes left. Session slides, please. Yeah, I believe that I can. You can find after this. We will send a link to our presentation. Kotlin or Java for beginners. For this, I used to use the Java not for mobile application, but for example desktop application. But personally, uh, I started developing mobile application using directly Kotlin because I believe that it's more easier to begin with, and also if you use Java, you will using Kotlin will be so easy to begin the mobile development. Does it work in any Windows or it must be Windows 10? Here I'm using the Mac OS because for the iOS side we need the Xcode IDE, which is provided only for the Mac OS, not for Windows. But if you want to build, for example, your web application, or you're not using the iOS side, even for mobile or desktop Mac OS desktop, you can use IntelliJ for any Windows. IntelliJ is provided for Windows platforms and Mac OS platforms. So, do you have anyone has some questions? Uh, I think that there is no questions. I hope that okay. Please, is there any live example for both iOS and Android? Uh, or, yes, if you need, I will send you. So you can check this for to create Android and iOS project for the Medium. Uh, there is a lot of Medium articles that you can read, and uh, you can create your first Kotlin multi-platform project. So there is someone saying that uh, أريد التواصل معك لأجل تقديم التطوع من مدرب سويفت لتقديم محاضرات معكم. أنا مبرمج. Uh, I think that they will respond you later. My host will, the host will respond you. how I can start as a beginner developer. Muhammad Dima, do you mean that which side? Do you mean like a web developer or Android developer? First of all, I think that if you want to mobile or even web, you have to take a look, first of all, of the programming language that you want to use, or even use the forums to have an idea about several languages and then use the most suitable for you. And you can find a lot of tutorials on YouTube for beginners for mobile or even web development. So you want to be an Android developer? Yeah. So you can start by searching for the Kotlin and instead have the basics of Kotlin, and then try to make your first app. With Android, we have a default project that will run the Hello World. You can find the several tutorials for beginners, and you can use the Stack Overflow if you have any bugs, and even you can ask your question there, or even use the GitHub platform to ask your question and have and experts will answer you, trying to fix your bug. So I think that's it. We have finished. We have only 3 minutes for saying goodbye. So we have another question. As a Linux user, how I can run my code for iOS? For this, I think that for Linux, I I'm not sure, but I think that you can have the not the Xcode IDE, but similar one to execute your iOS project. Or if you can't, you have to use a Mac OS. Okay, what is the best reference for Kotlin? So the best reference for Kotlin or Java or for the Android developers, you have their official website for Android developers. I think that I can show you. We have the Android developers guides. Here you can have all the stuff of Android project, and you have a lot of things. You can also check the Udacity courses about the Android. I believe that you can have for this Android developers, and the Udacity are the best ones. Should I buy Mac product to run? As I said, if you don't need to have the your iOS application, you only have to develop for Android, Windows, embedded system. You don't need to buy Mac product. But I think that for the iOS, iPhone or desktop macOS, you need to buy a Mac product. So we have only 1 minute left, and we're saying, can I work Android dev only with Java? Yes, of course. Yeah, definitely. Before JetBrains launched the Kotlin, uh, the mobile developers used to use Java and only Java, and it's still working. Okay, I think that's it's the time to say goodbye, and thank you for all your questions, and hope that you enjoyed this session. Thank you so much. Goodbye and have a good day.